questions 5 through 7 on the 2002 grade 12 Euclid math contest. What are the values of x such that log of x plus 3 to the base 5 plus log of x minus 1 to the base 5 is equal to 1? So we've got log x plus 3 to the base 5 plus log of x minus 1 to the base 5 is equal to 1. And if you remember, if you have the same bases, the log of a plus the log of b is equal to the log of a times b, like that. And just be careful, because that only works if the bases are the same. And for us, we do indeed have that situation, so we can multiply them like this: x minus 1, x plus 3. And then by definition, 5 to the exponent 1 is going to be equal to that expression, x plus 3, x minus 1. And at this point, this just becomes a regular quadratic style equation. So we got x squared minus x plus 3x minus 3, x squared plus 2x minus 3 minus 5 is minus 8 is equal to 0. So maybe this factors, instead of us having to do the quadratic formula, 4 and 2 perhaps, plus negative. I think that will do it. And there you go. X is equal to negative 4 or positive 2. Now, at this point, don't move on to the next question, or you'll lose some points. Can x be negative 4? And the answer is no. Why? Because you can't take the log of a negative number. So therefore, since x cannot be negative, the only value of x that satisfies this original equation is x equals 2. A chef aboard a luxury liner wants to cook a goose. The time t in hours to cook a goose at 180 degrees Celsius depends on the mass of the goose, m in kilograms, according to the formula t is equal to a times m to the power of b, where a and b are constants. The table below gives the time observed to cook a goose at 180 degrees Celsius, mass in kg, time in hours, and those numbers. Use the data in the table to determine a and b to 2 decimal places. So the fundamental equation is t is equal to a times m to the power of b. And they have given us 2 values for m and 2 values for t. And I think that should be enough, because if you substitute those in, you'll get, let's say, 2.75 for t is when m is 3. So that's the first one. And then 3.75 for t is when m is 6. And there you go. You got 3 to the power of b, 6 to the power of b. All right, so you got 2 variables, 2 equations, so we can solve. And this number, what is this? Number 5 has a log theme to it. So I'm very certain that solving this will involve logs, because they tend to group those kind of questions together. So here we go. Let's use these 2 to solve. The first thing I see is that if I divide, right? If I divide this by that, so I've got a 6 to the power of b divided by a 3 to the power of b, the a's will cancel. And therefore I've got to do the same thing for the other side of those equations, 3.75 and 2.75, like that. All right, so there you go. A's cancel, and we're just left with 6 to the power of b, 3 to the power of b, and this is about 1.36. Repeat. And at this point, we have just one variable. We got to solve for it. And we do that with logs, of course. So we got log of this side, 6 to the power of b, 3 to the power of b, log of 1.36, repeat, like that. And here we go. So again, another rule that if you have the log of a over b, this becomes the log of a minus the log of b, and this is only true if the bases are the same. And I haven't written any base yet. And if you don't write in a base, it is always assumed that it's base 10. Now you can put base 10, but in mathematics, if you don't put any number as the base, it is always considered base 10. If you want to put base 10, you can, but I don't, because why write an unnecessary number when you have to do this again and again? So the log of 1.36 is just a number, right? You can do that in your calculator, and it's 0.13469 approximately. And then now for this side, I will use my rule. It's not my rule. It doesn't belong to me. It's the rule. So there you go. Log of 6 to the power of b minus log of 3 to the power of b. And then as you know, the b's come forward like this. These are all standard log rules. If you're comfortable with logs, there should be no confusion as to what I'm doing, right? And then that's it. This should be actually a b, sorry about that. And we can factor out those b's. Log of 6 minus the log of 3 is equal to 0.13, like that. And then you just solve for b. You put that underneath log of 6 minus the log of 3. And it's all to the base 10. And as long as I haven't made any mistakes, this should work out. And this is just a number at this point. You just type it in your calculator and that kind of thing. It's 0.13469 divided by log of 6 minus the log of 3 is 0.3008, like that. And this is approximately 0.45. So b is equal to 0.45 approximately to 2 decimal places. All right, so we got b to 2 decimal places. Now we need to get a, because remember the question wants you to figure out, find both a and b to 2 decimal places. So how do we get a? Well, we can just use one of these equations. Either one will do, right? So let's just use the first one, 2.75 a 3 to the power, what was it? 0.45 for b. 0.45 like that. And then that's it. It's just straightforward mathematics. 3 to the power of 0.45 is approximately 1.6394. And then you just divide both sides by this to get what a is. And a is going to be approximately 1.677. To 2 decimal places, it'll be 1.68. And there you go. There's the value of a. And here is the value of b. Now we turn our attention to this guy here, part 2. Suppose that a chef wants to cook a goose with a mass of 8 kg at 180 degrees Celsius. How long will it take until his goose is cooked? All right, this is an expression, I think. I'm not familiar with the most recent slang or lingo in Canada, but I do remember hearing that when I was younger. Anyhow, so how do we do that? Well, we've already gotten this formula, right, in terms of something that we can work with, because we just figured out the values of a and b in our previous question. We got 1.68 for a, and b was 0.45. So substitute those in. So we got 1.68 m to the power of 0.45. That's our equation. And then m is the mass, and they're telling you that it's 8. So put that in there, 8 to the power of 0.45, and there you go. Do the math, get out your calculator, and calculators are allowed on the Canadian math contest, and this will give you approximately 4.2 4.28 like that. And this is in hours, right? Yeah, time is in hours. So 4.28 hours to cook a goose of mass 8 kg. In the diagram, A, B, C, D, E, F is a regular hexagon with a side length of 10. If X, Y, and Z are midpoints of A, B, C, D, and E, F, respectively, what is the length of XZ? So this guy right here. So let's blow this up a bit. So I think that should be sufficient. Now, we are not given too much information. We're just given that that is 10 and that these are the midpoints, X and Y and Z. So the only initial thing I know is that if X is the midpoint, that means that AX is 5, the length, because AF is 10, and this is a regular hexagon, meaning all sides are the same. That's what the word regular means. Hexagon, of course, means that it has 6 sides. All right, and they want you to figure out XZ, this distance. So where do we proceed from here? Well, the first thing I'm thinking of is trying to first figure out the angles. And then once we do that, things will fall into place. And also, I will need to cut this into segments like this. That and that, like that. That will help me because now, from here to here, watch carefully, that is going to be 10. Correct? It's the same as that side. I've made a rectangle. And therefore, this is a triangle with a right angle. And this distance in here, this little guy, I will call, I was going to call it X, but X is already there staring at me, so whatever variable you want to use, X is fine. I don't think you'll get too confused with that. Small x. And then I'm going to concentrate on that little triangle to figure out my value of xz all the way down. Because part of xz we already know is 10. And then very similarly, this distance right here is also x because it's exactly the same. It's symmetric. So let's concentrate on figuring out x, and we'll be able to figure out the value of xz. Now we have to turn our attention to angles. In a hexagon, the sum of all the angles are equal to what? Do you know? Even if you didn't know that, right? You say, well, I don't know what the sum of the angles are. A hexagon basically is 4 triangles. And the sum of the angles of a triangle you definitely know is 180. So 4 triangles would be 4 times 180, which is 720. Okay? The sum of all the interior angles, these guys that I'm drawing in orange, all of those add up to 720. But what about each of those? Each of those is equal because this is a regular hexagon, and each of them will be 720 divided by 6 because there's 6 of them. And therefore each is 120. Each interior angle of a regular hexagon. So now concentrate on this guy right there, that particular angle. We know it's 120. And we know from here to here is 90 because that's a rectangle. And therefore, this guy in here has got to be 120 minus that right angle. 90 is 30. So I hope I can squeeze it in there. There you go. What I'll do is I'll draw it a little bit bigger on the side so that it helps you kind of look at this triangle. So there you go. I just blew it up. Otherwise it gets really small. So there's your right angle in there. This is 30. And then if that's 90 and that's 30, then this must be 60, right? You can just easily do that. Some of the angles of a triangle are 180. Now I hope at this point you know, after so many math contests, that in a 30, 60, 90 triangle, the ratio of the sides are 1, 2, and root 3. Not necessarily the lengths, but the ratios. we know the lengths from here to here. Look at the diagram carefully. It was 5. And then this length, which is the one we are most interested in, is x. And therefore we can figure out x just from this 30, 60, 90 triangle. X over 5 will be 1 over 2. Right? Those are the ratios of the sides. And therefore x is equal to 5 over 2. And there you have it. We have everything we need now to figure out the value of xz, which is the distance from there to there. Xz, I'll write it up here, is what? It's basically this distance, x, plus the next segment, which is 10, plus that final x, like that. 2x plus 10. X we figured out over here is 5 over 2, so plug that in. Plus 10, and therefore we've got 5 plus 10, which is 15. So there you go. The value of xz is 15. Our next question says, a circle passes through the origin, and the points of intersection of the parabolas y is equal to x squared minus 3, and y is equal to minus x squared minus 2x plus 9. Determine the coordinates of the center of the circle. So first, let's draw a diagram to figure out exactly what it is that they are asking us in this question. So we've got a axis like this, and the first thing is that we've got two parabolas. The first parabola, very rough sketch here, is approximately here, right there. Y is equal to x squared minus 3. So it's basically y is equal to x squared, but it's translated down 3 units. So it's approximately like this. Rough sketch, okay? Not beautiful, but it serves the point. Now let's draw that one. Now I know for a fact that because this is a negative right here, the coefficient in front of the coefficient in front of the x squared is negative, that's going to be a parabola that's going down, right? This one was going up because the coefficient here was 1. Now, very quickly, we can figure out the y-intercept by setting x equal to 0. It's about 9. So very roughly, it's going to look something like this. Something like that, where it kind of cuts through approximately. Okay? Now, look at what the question says. The points of intersection. So what are the points of intersection? And like I said, this is just for understanding purposes. Doesn't really have to be drawn to scale. The points of intersection I'll draw in red right here and right here. And then you have a circle. And the circle, when you draw it, it must pass through these two red dots. A circle passes through the origin and the points of intersection of those two parabolas. So let's draw a circle that points are the origin and these 2 points of intersection. So here we go. After much trial and error, I got the diagram to look approximately the way it should. So this green one is y is equal to x squared minus 3, and the orange one is y is equal to minus x squared minus 2x plus 9. And the circle, the almighty circle that we are most interested in, passes through the origin right there, that red dot, and passes through the points of intersection of those two parabolas with those 2 red dots on the diagram. All right, now we have to figure out the center of the circle. So the center of the circle is approximately, approximately there, that red dot that I just put in. Okay, so I hope you understand how this is all set up. So now where do we proceed? One thing I want you to understand is something that we can label pretty easily, and that is the radius of this circle. And we are given quite a few clues. So I've got, for example, if this is the center, then this is the radius. I'll draw it in red to make it a little bit more obvious here. So this is the radius, right? And the radius is also represented by the center to the origin, because the origin is a point on the center, on the circle I should say. And finally, from the center to this point is also the radius, because that point is on the circle. So we'll just label them R so that you know this is R, this is R, and this is R. All right? And the first thing we need is these coordinates. What is this? What is this coordinate? This one we know is the origin, so that's 0, 0. And then finally we will have to figure out that, which is exactly what they want us to figure out, the coordinates of the center of the circle. So I'll call that XY, obviously, and C for center. All right, so here we go. Very first thing I want to do is I want to figure out these guys right here, those two. That's going to help me. And how do I do that? Well, they are the points of intersection, these two parabolas. So set those two equal to each other. So move this up a bit. So if I set them equal to each other, I'll get x squared minus 3 is equal to minus x squared minus 2x plus 9. All right? So we got 2x squared is equal to, put everything on one side, plus 2x minus 3 plus 9 is plus 6, like that. And then, sorry, that should be negative 12. You're subtracting 9 from both sides, not adding. So this looks like you can divide through by 2, so you got x squared plus x minus 6, correct? And I think this factors. We don't need to use a quadratic. X 3, 2 plus negative, like that. So therefore x is negative 3 and x is 2. So this point here, it looks like 2 something, and this point up here is negative 3 something. All right, so that matches our graph. And we have to, of course, figure out the y coordinates, and we can easily do that by plugging them into either of these parabolas. So if x is negative 3, it'll be 9 minus 3, which is 6. So this is 6. And when x is 2, that'll be 4 minus 3, which is 1. So that's 1. All right, perfect. We got everything in terms of our coordinates. Now we move to the next part of the question, which basically says that we have 3 radii. And those 3 radii, of course, are all equal. They're all the radii. So we can figure out the distance from the center right here to each of those 3 points. And the distance from the center to each of those 3 points is the radius. So therefore all of those will be equal. And we can then set them equal to each other to figure out the coordinates x, y. So first I'll do the center to the origin, this guy right here. So that will be x minus 0 all squared plus y minus 0 all squared, all under the square root sign, and that is equal to the radius. Correct? That's how you find the distance between 2 points. And now let's concentrate on this guy right here. That will mean x minus 2 all squared plus y minus 1 all squared is equal to the radius. And then lastly, that one, that radii, x plus 3, because it's x minus 3, and then y minus 6, all under the square root sign, is equal to r. So that is basically how we proceed. These are our equations, and they all are equal to r, so we all set them equal to each other. This is 0 in here. I think I forgot that 0. All right, so where would you like to begin? Either way, either direction, any direction is fine. I'm going to first start, let's see, well, let's start with these two here. So that means x minus 2 squared plus y minus 1 squared, all under the square root sign, is equal to x plus 3 squared plus y minus 6 squared, like that. Square both sides, get rid of that radical, and we get left with just what we have inside the radical. And then, of course, at this point, you are going to expand. So let's do that. X squared minus 4x plus 4, y squared minus 2y plus 1, and then we got x squared plus 6x plus 9 plus y squared minus 12y plus 36. Okay, no mistakes, hopefully. X's go, x squareds go, I should say, y squareds go. And let's put everything on one side. Let's see what we get. Minus 4x, 6x. So if we bring that 6x over, it will become minus 10x. Minus 2y, minus 12y. So we're adding 12y to both sides, so this becomes plus 10y. And then 4 and 1 is 5. 9 and 36 is 45, so 5 minus 45 is minus 40. So there you go. So 10, we'll isolate for y, we'll get 10x plus 40, and then divide through by 10, you'll get x plus 4. Okay, so we didn't get any actual numerical values, but we got a pretty good relationship. Now, I'm going to look at, let's see, anyone, doesn't really matter. How about just these two? That should work. So first I'll write it out, and then I'll push this up a bit. So we've got this guy here, all under the square root sign, is equal to x minus 2 squared plus y minus 1 squared, like that. All right, let's push this up now. First thing, of course, get rid of the square root signs by squaring both sides, and then x minus 0 is just x, and then y minus 0 is just y. So that side becomes pretty clean. And then now, of course, we've got to expand this. X squared minus 4x plus 4 plus y squared minus 2y plus 1, x squared plus y squared. X squareds go, y squareds go. We just get left with, what do we get left with here? Minus 4x minus 2y plus 5, correct? Yeah. All right, good news is we know why. It's in terms of x now. We can substitute that in. That will definitely help us. Instead of y, put in x plus 4 from up here. And we can now solve for x. So we got minus 4x, minus 2x, minus 8 plus 5. So we got minus 6x minus 3. And then 3 is minus 6x. And therefore x is equal to 3 over negative 6. And that is negative a half. So we got the x-coordinate of our center. Now we just need the y-coordinate and we're set. So y is equal to x plus 4 from up here. So we got minus 1/2 plus 4. And let's see, this is a fraction, 8 minus 1 is 7, 7 over 2. So there you go. Our center xy is negative 1/2, 7 over 2. Negative 1/2, 7 over 2. Let's go back to our diagram. So this guy right here, negative 1/2, 7 over 2. And that's what they wanted us to figure out. In the diagram, AC is equal to 2x. BC is equal to 2x plus 1. And the angle ACB is 30 degrees. What is the value of x if the triangle's area is 18? So let's blow this up a little bit. So here we go. We want to figure out the area of this triangle in terms of the length and the base. So I'm going to draw a perpendicular like that. And of course this will be a right angle since it's a perpendicular, and I'll label it H for height. And the area of a triangle, as we all know, is basically 1/2 base times height, correct? Now the area they gave you, the numerical value is 18. And then they also gave you a value for the base, but it's in terms of x, but that's fine. We can put that in there. And then if the height, I created a variable h. Now they want you to find this value of x. So how do we do that? Well, the reason they gave you this angle is because they want you to use trigonometry. And trigonometry will definitely help you if you use which? Sine, cos, or tangent. Okay, think about it for a few seconds. In my humble opinion, sine will help you the most. So sine of 30, in this case, if you look at just this triangle right here, that guy will be opposite over hypotenuse, correct? So that would be h over 2x, like that. And therefore h is equal to 2x sine theta, sine 30. And now instead of having this x or h there, I can put this guy in there. So we've got 18 is equal to 1/2 2x plus 1 times 2x sine 30. And I hope we can now solve for x. So we can say 18 is equal to this 2 and this expression will cancel, become 1. So we got just 2x plus 1 times x. And then the sine of 30 is 1/2, like that. All right, so cross multiply this 2 right here with the 18, you'll get 36. And then let's expand this out. So 2x squared plus x. All right, and this point, it's just like a quadratic. So we got 2x squared plus x minus 36 is equal to 0. And let's factor and see if we can get something without a quadratic. I think 9 and 4 should do it. 9 and -4, plus 9 and -4. So we have 2x squared minus 8x plus 9 would give you 1, and that's how you get this coefficient of 1. All right, that works. So that means x is equal to either minus 9 over 2 or 4. Now x is obviously a length, so it can't be negative. So therefore x must be equal to 4. So there you go. That is the answer for 7A. A ladder, AB, is positioned so that its bottom sits on the horizontal ground and its top rests against a vertical wall, as shown. In this initial position, the ladder makes an angle of 70 degrees with the horizontal. The bottom of the ladder is then pushed 0.5 meters away from the wall, moving the ladder to position A-B'. In this new position, the ladder makes an angle of 55 degrees with the horizontal. Calculate to the nearest centimeter the distance that the ladder slides down the wall, that is the length of B'. So let's create this diagram, but in two separate scenarios. The first when it's at B, and the second when it slides down to B'. So the first diagram basically is when it's in its initial position. So this is B and this is A, and this is 70 degrees. The next diagram I wrote was when it slides down. So that's B' and this is A' and this is 55. Okay? And basically I'm going to use trigonometry. That is the reason they gave us these angles. And let's start by working with this distance from B all the way down to the ground. So that's BC basically, since this is C, and I'll call that H. All right, so let's go with that. In this diagram right here, I've got basically sine of 70 is equal to H over AB, correct? AB being the hypotenuse. Now AB is the ladder, and do they tell us anything about the ladder? In terms of its length, they do not. So we've got to just use, I guess, L for ladder instead of AB. Or you can use AB, but I think L would be a little bit better. All right. Now, we don't know anything in this question in terms of H or L, but we just know this relationship. So what I'm going to do is write everything in terms of L. So that means that L is basically H over sine 70, or you can write that H is equal to sine 70 times L, like that. And the sine of 70, the numerical value, is 0.9396 L, like that. So instead of putting H, I'll just put 0.9396 L. I think 4 decimal places is good enough. And in a very similar way, I'm going to figure out this length here, AC. And that would probably involve cosine. So we have cos of 70 is equal to AC over L, and therefore AC is equal to the cos of 70 times L, like that. And the cos of 70 is equal to approximately 0.342, like that. So I'm going to then label AC as 0.342L. All right, so I've got everything in terms of L. Now we turn our attention to this situation here. Now, when it slides from A to A dash, they tell you some very important information, that it is 0.5 meters, this right here. When it goes from A to A dash, it moves 0.5. So that basically means that this distance right here, A dash to C, is 0.5 greater than AC. So AC I have in terms of L, 0.342L, and then I'll add 0.5 to make it the full distance A dash to C. Okay, so that's what we have so far in the initial setup of the question. So let's now concentrate on this diagram using this angle 55. Using that angle, there's several relationships, sine and cos, but since I have the adjacent side, I'm going to concentrate on the adjacent side, and therefore I'm going to use cosine. Cos of 55 is the adjacent, which is 0.342L plus 0.5, and divided by the hypotenuse. The hypotenuse is the ladder. It's the same ladder. Ladder has not changed, so that's L. All right? Now you just kind of go through with this. This is really just a math problem, simple math problem where you have just one variable, and that's L. So cos of 55, you can convert that to a numerical value, 5.73, multiply by L. And this is 0.342L plus 0.5, like that. And then subtract both sides and you get 0.2315L is equal to 0.5. Right? And then solve for L, you get 0.5 divided by 0.2315, and that's approximately 2.16. All right? So what do they want us to figure out in this question? They're saying that initially it was at B, correct? They want you to figure out this distance right here. I'll put it in red. When it slides down, what is the value? So that distance right there, from B to B dash. Okay, we should be able to figure that out. So now I'm going to use the angle 55, but now I'm interested in the opposite sides, so I'm going to use sine. So the sine of 55, if you look at that diagram, is B dash C over the hypotenuse, which of course is our ladder, correct? And sine 55 times L, therefore, is the length of BC, B dash C. Now L we figured out was 2.16, so we just have to go sine 55 times 2.16, and that should give you the length of B dash C. And this is approximately equal to 1.769. All right, so that is a very important number. Now we have this part here. If we can figure out from B all the way down to C, then we just subtract these two to get B down to B dash. So how do we get BC? Not B dash C, but BC. Well, we have to then use the first triangle, this one right here, BAC, like that. And if you remember, in that triangle, the sine of 70 was equal to BC over the hypotenuse, which is the ladder. And therefore, BC is the sine of 70 times L. Correct? So we'll put that down here. Or we can just figure it out up here. No need to place it anywhere else. Sine 70 times L. L we figured out was 2.16. Like that. And therefore BC is going to be, in terms of a numerical value, 2.029, like that. So there you have it. We've got the distance BC, which is B all the way to C down there, and we've got the distance BC, B dash C, all the way there. So to figure out our B dash B, our final step, B dash B or B dash, whichever way you want to say it, is basically BC minus B dash C. And then that would be 2.029 minus 1.769, and that is 0.26. Correct? And just one little extra detail is that they want it to the nearest centimeter, and we were dealing so far in meters. So this is meters, so that to the nearest centimeter, it would just be 26 centimeters, like that. And there you have it.